Let's look at 2.2. So this is more on functions and their graphs. We are going to look at how functions increase and decrease and remain constant. We're going to locate the maxima and the minima, test for symmetry, identify even or odd functions and recognize their symmetries, and then look into piecewise functions, and then find and simplify functions difference quotient. So here's the information on when functions are increasing and decreasing. So a function is increasing on an interval if f of x1 is less than f of x2 when x1 is less than x2 for any x1, x2. So if you look at the graph, it's easy to see where it's increasing. Here's a decreasing function. We have a greater than symbol with a less than x1 to x2. So basically what we are doing, what this means is on the graph, we're looking from left to right, just like we read a book or read a sentence. We are reading it from left to right, and we are looking how the y values move. So this one, it's moving up. So this is an increasing function. This one, reading from left to right, the y values are decreasing. So that's what that is representing. And then constant, moving from left to right, the y value remains constant. It's a straight line. So let's look at this first example. State the intervals on which the given function is increasing, decreasing, or constant. So we see that this from here to here is increasing. From here to here, it's decreasing, so I'm putting in minus. Then from here to infinity, so this is going down to negative infinity, up to infinity, it's increasing. So increase, increase. Those are both increasing. Remember, we're moving from left to right. So this is increasing. So that's from negative infinity up to the x value of -1. And then from -1 to +1, it's decreasing. -1 to +1 is decreasing. I'm going to put that in orange. It's going downhill. And then from 1 to infinity, going to the right, remember we're reading left to right, it's going to be increasing. So it's increasing from negative infinity to 1 and 1 to infinity. Decreasing from this right here. So you're looking at x values whenever you write your intervals. We don't care about the y values. And this infinity means it's going right to infinity, left to negative infinity. Always look left to right. All right, so let's look at this function here. Oh, that shouldn't have been there. I should have deleted that. Sorry. So this is here. Using a graphing utility to graph the function, we are going to look at this as our window and then find the intervals when it's increasing, decreasing, or constant. I'm going to show you how we can use the calculator. So go to y equals whatever is in there. Go ahead and clear it out. And let's put it in x to the third power minus 3x squared minus 9x plus 2. And we want to do our window. So this is our window. So these are the x's and these are the y's. So that's what our x's will be. Sorry, you can't see that. There we go. All right, so go window. X min is going to be -5. X max is 5. Scale is 1. Y, -27, 7, and 3. Okay. So it should look like this, but this has a graph on it. So we need to find where it's going through and what it's looking like. So I'm going to hit trace. And it's saying that that y-intercept is at 0, 2, 1, 2. Let's find out where this changes direction, because it It's increasing here, and then it decreases that whole way. Then it increases. So let's find out what that point is. So let's go. I hit trace a minute ago. Looks like it's at -1.7. Let's see if that's on the table. -1.7, so 6, 7. And it is. Well, I can go ahead and get a couple of points anyway. -2, 0. -3, 25. And then I have 1, -9. 2, -20. 3, -25. So it looks like that, right? And then 4, -18. So it comes back up. 5 is up here at 7. It looks like that. So that's a rough estimate. So go ahead and create the line. There we go. And so should look very similar. So let's look at our increasing. This should not be here. So I'm going to put increasing here. So it's from -infinity up to this point, to -1. And it's also increasing from 3 to infinity. So this and this. So you're always reading left to right. So from here, you always go left to right. I'm trying to go the other way. So see how that's increasing? And this is increasing. It's going up, up, up. Okay. So then our decreasing is from here to here. So that's from -1 to 3. So decrease -1 to 3. So always read left to right. So start here, go up, increase. Here, down, decrease. Here, up, increase. Okay, let's look at the next one. It's already graphed on here for us. So it says we want to look for increasing. So there are none. See how this is, we were reading it left to right. So here to here, that's constant, right? It's not going up or down. So remember our x value, so it's going to keep on going this way. So that's -infinity to 2 is constant. And decreasing would be 2 to -infinity. And we're looking at our x value. So it's not -infinity, it's positive. Our x values going this direction are positive infinity. Our x values going this direction are -infinity. So we're only looking at x values when we're doing intervals of increase, decrease. And then no interval of increasing, so we put none on here. So this is our negative. This is our constant. Okay, so relative max and min, relative maximum, relative minima, is you can't get, like if I look here, my maximum, well, it's going to keep on going on and on and on, so I can't actually find a maximum. So instead, I'm going to do a relative. In relation to the rest of this graph, what's our maximum? So when we're dealing with our maximum and our minimum, we're looking at y values. We're not looking at x values. X values are intervals of increase, decrease, and constant. Relative max and min are y values. So if I look here, my maximum y value would be 6. My maximum or minimum y value would be, what is that? Negative 25, I believe. I think that's what it was. So that's what we're looking at. So the word local is sometimes used instead of relative when describing maximum and minimum. So we're looking for our relative maxima and our relative minima. So whenever we look at this example, relative maxima is right here. A relative minima is here. But this is talking about where our x is. So our x is located at the -1. So we're wanting to see on this one is the relative maxima. F of A is going to be our y value because it's x, y. So here they wrote x is -1. Well, what is y? Y on this one, it looks like 1 also. This one, oh, that's so hard to see. -1, -2, maybe -3. So it depends on what are we looking for. Are we looking for the x? We're looking for the y value. But you can find the location of our maximum and the location of our minimum. And it'll be dependent, what you put in as your answer will be dependent on what is it asking for? Is it asking for your x or is it asking for your y? So use this graph to find the relative maxima and the relative minima. And you can have more than one. So let's do our maxima. Maxima is here. It's at 3, 4. Okay. So it'll depend on what it's asking for. So 3, 4. So if it's asking for x, it'd be x equals 3. It's asking for f of x or y. It's going to be 4. And then this goes on the next sheet. All right, so let's look at our minima. So it'd be here and here. That's at 2, 0. And this is at 4, 0. So what are these relative minima? 2, 0 and 4, 0. So I just want to make sure I was giving you the right information, so I looked at an example. So this problem, the way it's written, so it says relative. The function has a relative maxima at -2. So -2 is going to be your x. And the relative maxima or maximum is 53. So at -2, 53, that is your relative maximum. At your minimum, at 3, negative, you see my mouse, -72, that's your relative minima. So at is your x and is your y. So let me go back to that example we had. So on this one, the relative maxima is at 3, which the max is 4. You have a relative minima at 2, which the relative minima is 0. You have a relative minima again at 4, which the minima is 0. All right, so let's look at this example where we do not have the graphed out solution. We have to graph it. So let's go to our calculator again, clear out whatever is in there, and then we're going to change the window. Let's get it over. There we go. 2x to the third power minus 6x squared minus 18x plus 5. Oh, look at what I did. 2x to the third, so don't do what I did, minus 6x squared minus 18x plus 5. All right, and then we want to change our window to, if we look here, it's -5 to 5 with a scale of 1, and then -60 to 60, and our scale is 10. And the way I knew that is I was looking at our x min, x max, and then down here, and then up there. So hit graph, and let's look at it. All right, so we need to graph some points. That'll help us. So our calculator will actually find some maxes and our mins for us. So the way you can do it in your calculator is graph first, graph, and then change window, whatever it needs to be. And then you're going to go to second trace, which is calc. And we want to first let's find our maximum. So 4 maximum. And I'm going to find the maximum here. So see how it says left bound? I'm going to find out where it's at. So that's about where it's at, which looks like it's -1, 14, 15, I don't know. I think it's 15. But let's go ahead and just go to the left side of it. And then right side, see how I'm arrowing over to the right side of our maximum. Our maximum's here. Left side's over here. Right side's here. Guess, enter. And that rounds to -1, 15. So if you need to, you can rewind and watch that again. Or we can go to the table of values, -1, 15, -2, 1, -3, 50, 0, 5, 1, -17, 2, -39, 3, negative, and then 4, 35, 5, 15. Okay, so you kind of get the idea. Something like that. Go back to the graph. You can hit trace. You can move it left and right, or you can do, like I said, the second trace, and you can do max, and then you can go back and do your minimum. Well, we know what that minimum is, but it'll show us anyway. So go minimum, and I'm going to go take my little point that I have and go down to the minimum, and then I want to go to the left of it. So I'm going to come on this side. And it doesn't matter how far you go. I'm going to go right there. Enter, and then go to the right of our minimum. That's to the right. Guess, enter. 3, -49. Okay, so it'll be the relative maximum is at -1, and the maximum is 15. The minimum is at 3, and the minimum or minima is -49. All right, let's keep on going. Symmetry. Test for symmetry. So symmetric. Things are the same on both sides. So to test for symmetry, we have 3 different things we're testing. Is it symmetric about the y-axis? So if you flip it or reflected across the y-axis, is it the same? And so that's for the y-axis. Is it symmetric about the x-axis? If you flip it up to down or down to up, they're the same if it's symmetrical. And then there's one other one, symmetrical about the origin. If you can flip it across the origin diagonally, then you can have symmetry there too. So if it's symmetrical with respect to the y-axis, then if you have x, y, the point negative x is the same, negative x, y is the same as x, y. So substitute in negative x for x, and you should get an equivalent equation. This is about the y-axis. This one is symmetric about the x-axis. If you substitute negative y for y, and you get an equivalent equation. The origin, if you substitute both, negative x for x, negative y for y, and you get the same equation. So you have 3 different tests. So for the y-axis, you're going to sub in negative x for x. See if it comes out to be the same. X-axis, sub in negative y for y. And the origin, sorry, I had to do it up here. You're going to do both sub of these. And you're going to solve and see if you come up with the equivalent. All right, so I do have an example. So determine whether y equals x squared minus 1 is symmetric with respect to y, x, and origin. So the first one is the y-axis. Substitute in negative x for x. So every time you see an x, you're going to substitute in a negative x. So here's our original equation. Substitute it in. Anytime you square a negative, you get a positive. So see how it's the same? So that means it is symmetrical about the y-axis. So then the next one, we're going to do the x-axis. See if it's symmetrical about the x-axis. So you're going to sub in negative y for y. So here's your original. I substituted in negative y. Well, whenever we want to graph it, we always want to get it to say y equals. So you're going to divide everything by a negative 1. So I wrote out what we did. So whenever it came out this. These are not the same. Equation is not the same, so it's not symmetric. The last thing is you're going to sub in negative x for x and negative y for y. So see how they subbed it in. So this negative x squared comes out to, they didn't do the intermediate step. It'd be negative y equals x squared minus 1 divided by negative 1. Which gives you y equals negative x squared plus 1. Not the same, so it's not symmetric about the origin. So you have 3 tests to do. Is it symmetric about the y, the x, or the origin? And we can look at what that looks like. So I'm going to bring my calculator back up. I'm going to clear what's in there and just put in my new one, x squared minus 1. And I'm going to go back to my original graph. So I'm going to, whenever I graph it, I'm going to hit zoom 6, and that's zoom standard. Can't see that. There we go. Zoom 6 says standard. All right, so look at it. Look at the y-axis. See how it's the same, it's symmetrical. Whatever I have on the left side, it's the same as the right. That's symmetrical about the y-axis. I kind of drew it over here too. So if you look at it, you can look at it and tell and see if it is symmetrical. All right, let's look at this one. So we first need to test the y-axis. So we are going to sub in negative x for x. So we have y equals 3x minus 2. So y equals 3 times a negative x minus 2. That's y equals negative 3x minus 2. So this is a no. All right, x-axis, we are going to sub in negative y for y. So negative y equals 3x minus 2. Solve for y, so divide by negative 1. We get y equals negative 3x plus 2. And that is not the same, so this is a no. All right, and then our last one is the origin. So we are going to sub in a negative y for y, negative x for x. We get negative y equals negative 3x minus 2. Divide by negative 1 all the way through. Y equals 3x plus 2. That is not the same, so it's a no. So it's not symmetrical at all. No symmetry. No symmetry at all. All right, let's go to the next one. Determine whether it's symmetrical. So let's go ahead and look. So we'll do the, what was the first one? I need to look back at my notes. So it's x-axis, right? No, it's y-axis. Y-axis. I'm going to sub negative x for x. So we have y squared equals negative x squared plus 15. Anytime you square it, you get a positive, so it'd be x squared plus 15. Same. So symmetric about the y-axis. Okay, so the next one is x-axis. So this one we are going to sub in negative y for y. So if you need to look back, you can look back at the instructions right here. Or one more back over here. Sub in negative y for y. So that means we're going to put in negative y squared equals x squared plus 15. Well, anytime you square something, the negative goes away. So that's good. They're the same. So there's symmetry about the x-axis. All right, our last one, we're going to sub in both at the same time. Origin. And negative x for x. And negative y for y. So negative y squared equals x squared plus 15. Oh, I forgot to sub in. There we go. Negative x squared. Square something, you come up with the same thing. Square and negative, Square and negative, you get a positive, so that's why it's like that. They're the same. So there is symmetry about the origin. All right. So that's enough about symmetry. Let's go to even and odd functions. If f is an even function, then f of negative x equals f of x for all x in the domain of x. The graph of an even function is symmetric with respect to the y-axis. So this one, I guess you can only be even. Can you be even and odd? I don't know. Then the odd function is whenever you do f of negative x equals negative f of x. It's an odd function if it is symmetric with respect to the origin. So let's look at this. Just looking at the graph, we look and see, is it symmetrical about the x or the y-axis? Look at this. They are the same on both sides. So it's symmetric about the y-axis. Because it's the same on both sides. There's a reflection. Okay, so that means that if it's about the y-axis, then it's even. Okay, the next one, if we look at this, it's not a reflection. If we look at this, it's not a reflection of any sort, like flipping it over. This is neither, not even or odd. If it went right through the origin and did this, then that would be an odd function. So identifying even or odd from equations, you're going to plug in a negative x and see if it is the same for even. You are going to plug in an odd changes sign if x is replaced with every term on the right side of an equation of an odd function changes sign if x is replaced with negative x. Neither if that's not equal or in that one. The right side of the equation changes if x is replaced with negative x, but not every term on the right side. Okay, so we have an example identifying even or odd from here. So we have x to the fifth plus 1. So what it has us do, it has us plug in negative x. So anything to an odd power is going to be a negative. So that's why that comes out to be a negative. So you got to think back to negative 1 squared is positive 1. Negative 1 cubed is negative 1. Negative 1 to the fourth is positive 1. Negative 1 to the fifth is negative 1. So that's why this comes out to be a negative x to the fifth. So we look and compare them. So the only sign that changed was the x, not this one. So it is not even. So then we do the same thing here. We're going to plug in a negative x, and we get this. And then we are going to look at what this is and distribute the negative to everything and see if they're the same. They're not the same, so it's not odd. So it's neither odd nor even. So let's look at this example. X to the third minus 6x. So we are going to test out if it's even. And the way we do that is we are going to sub in negative x for x. So f of negative x equals negative x to the third minus 6 negative x. To the third power, it's going to stay the same, negative. So negative x to the third. And then negative times negative becomes positive 6x. So if we look here, there are two terms on the right side of the given equation. Each term changed sign when we replaced. Because of this, it's an odd function. F is symmetric within the origin. So if we look at it, this f of negative x is negative x cubed plus 6x. If we do negative f of x, we get negative x cubed minus 6x, which you distribute that, and you get negative x cubed plus 6x. So these are the same. F of negative x is equal to negative f of x. So whenever we got that, f of negative x equals negative f of x. So I knew it wasn't even because f of negative x did not equal f of x. So see how they were different? And they were different by both of them were changed some, but they're the exact same, which is the same thing as doing negative f of x. So it wasn't even. So this means not even because of this. But it is odd. Because of this. And that came from here. F of negative x equals negative f of x. Okay, so let's do this one. Let's do f of negative x here. So it'd be negative x to the fourth minus 2 times negative x squared. Whenever you do to an even power, the negatives will cancel. So this is going to give us x to the fourth. This is going to be positive 2x squared. So it's the exact same. So this f of negative x equals f of x. So it's the same. So if it's the same, that means it is, let's look at it, an even function. This one was odd, this one's even. So even means, let's see, what does even mean? What does odd mean? Go back to our notes. Even means it's symmetric with respect to the y-axis. Odd means it's symmetric about the origin. So our odd one was this one. So symmetric about the origin. And then this one was even, so it's symmetric about the, let's see, y-axis. Because that's what even means. So it could be neither, but in this case, we have an odd and an even. Okay, the next topic is piecewise function. A function that's defined by two or more equations over a specified domain is called piecewise. So here's a piecewise function. So we have this function for all x's that are less than 0. So that means -3, -2, -1, and all the way up to, but not including 0. Not including 0 or anything greater than that. So -4 is also there, and so on. This one, x is greater than or equal to 0. So that means we start at 0 and we go up. So we have basically two different equations, and you've got to look at when the x values are certain equations, you use a specific equation. So on A, f of -2, we are going to use this one. When x is -2, x is less than 0, so this is the function we're going to use. 3 times -2 plus 5. So that'd be -6 plus 5 equals -1. B, f of 0. So we're looking at when x is 0. So it's not the first one because x is only less than 0. So we use the second one. 3 times 0 plus 7, which gives us 7. C, f of 4. So this is when x is greater than or equal to 0. So this is the function we're going to use. 3 times 4 plus 7. So that's 12 plus 7 is 19. So this is going to have two different functions depending on what your x value is. So here's an example that's worked out for us. We have C of G. C of G equals 40. when g is between 0 and 15. But when t is greater than, I think that should be g. Let me double check my work. T equals 100, C of G. So this should be G. It was just a mistake. So whenever G is greater than 15, you're going to plug it in here. So when G is greater than 15, that's like saying 16, 17, 18, and so on. When G is between 0 and 15, it is just equal to this equation. So any number in between 1, 2, 3, 4, all the way up and including 15. This does not include 15. So C of 5 falls in this category, so it just equals 40. There's nothing to do. 50 though, 50 is going to fall in this category, this equation. So we're going to use this equation, 40 plus 0.60 parentheses G minus 15. So we're going to plug in the 50, go ahead and subtract it, then multiply those, and then do 40 plus 21, which gives you 61. So G of 50 is 61. When you do a piecewise function, you need to make sure to look at what value you're given for x, and that'll determine which value you're going to use. So given this function, we are going to look at f of x equals 3 when x is less than or equal to negative 1. F of x equals x minus 2 when x is greater than negative 1. So for any values less than or equal to negative 1, it's just going to equal 3. So that is this right here. See how all these values are negative 1 or less than? It just equals 3. So here's your function. If x is greater than negative 1, then we're going to plug in this. Greater than negative 1, we're going to use this because this is going to have an open circle because it's not actually equal to it. So negative 1 to negative 3. Whenever you plug in a negative 1 here, you get a negative 3, so that's why that's there. When you plug in a 0, 0 minus 2 is negative 2, so our equation or our point is 0, negative 2. Plug in a 1, 1 minus 2 is negative 1, so you get that. So then you're going to plug in these points in here. So we have negative 1, 3, negative 1, 3, negative 2, 3, negative 3, 3, and so on. So it's going to be a line that goes on and on to infinity here. The other equation is x minus 2. So our point was negative 1, negative 3, which is here. It's an open circle because this did not have an or equal to sign. So that's why it's open circle. Then you do 0, negative 2, 1, negative 1, and so on. So this is a piecewise function. We have two different functions graphed on here. For anything where x is negative 1 or smaller, it looks like this. Where x is negative 1 or bigger, it looks like this. So let's look at this one, where we have 1/4 x squared if x is less than 4. So x, y. So we'll go ahead and do 4, 3, 2. So we'll plug in that. So this is the y equals 1/4 x squared. So I'm just going to put that into the calculator. So 1/4 4 squared. It's 4. 1/4 3 squared. 9/4. I can hit math decimal. 2.25. And then plug in a 2 here. Equals 1. And this will be an open circle on 4, 4. So go 4 up to 4. 3, 2.25. 2, 1. And then let's do one more. 1, 1/4. No, I'll do 2, 0. So 0, 0, 1, so it's like that. And it's going to keep on going. So let's see what it looks like on y equals 1/4 x raised to the second power. So it's going to look like that. So it's going to go, oh, because I graphed it wrong. I was like, there's something wrong with it. Sorry. There we go. I knew something was wrong. I didn't know what. And then it would be 1.25 because it's, or negative 1.25, negative 4, 4, and so on. Negative 2, 1, negative 3, 2.25, like that. So this is going to keep on going. Okay, so where x is greater than or equal to 4, it's going to be this function. So x, y. X is greater than or equal to 4. So we're going to find out what 4 is. And this is going to be a closed circle. So 4 times 4. 4 times 4 minus 10. 6. So at 4, 6, you're going to have a closed circle. Okay. Greater than or equal to 4. So we'll go 5. 4 times 5 is 20 minus 10 is 10. So 5, 10. So this is a linear function, so it's going to go up like this. So this is what the function is going to look like. So this part is quadratic because it has a squared. This part is linear. All right, our last subject, or our last concept, y'all stay with me, is called a difference quotient as a function. So whenever we do a difference quotient, we are going to use this. So it's with function notation, and you're going to simplify. So f of x is 7x. So if I do f of x plus h, that's going to mean anywhere I see an x, I'm going to plug in x plus h. Minus, hold on, let's go ahead and simplify that. Distribute, that would be 7x plus 7h. So if I'm using this as my difference quotient, f of x plus h is this. So it'd be 7x plus 7h. And then minus, f of x is 7x. So this part right here was f of x plus h. This part right here was f of x, just like our equation. And then over h is just h. And then you would simplify. So on the top, I can simplify 7x minus 7x. That becomes 0. So all I'm left with 7h over h. H's will simplify out, and that just gives us 7. Okay, so the difference quotient is 7. Let's look at the difference quotient of this next one. So f of x is 7x squared. So let's do f of x plus h, which gives us 7x plus h squared. X plus h, you have to use the box. X plus h times x plus h. X squared, xh, xh, x squared. This gives us 2xh. So this is 7x squared plus 2xh plus h squared. All right, so it says f of x plus h minus f of x. So this would be, oh, we forgot to distribute. So it'd be 7x squared plus 14xh plus 7h squared minus 7x squared, because this is my f of x right here, all over h. Okay, simplify out. These two are going to cancel each other out because they are the same. So now we have 14xh plus 7h squared over h. I could simplify out an h out of both of them. The only way you can do this is simplify it out of both, which what this really means I'm doing is I'm splitting up each numerator with a denominator, like this. And so I can simplify out like that. And so now I have 14x plus 7h. All right, last example. We have negative 2x squared plus x plus 5. We are going to look at how to simplify this. So we have, let's see. F of x plus h, we have negative 2, and then the x plus h for x plus 5. So we've already done this once. So I'm going to do negative 2. That was this up here, which was x squared plus 2xh plus h squared. This is just the x plus h squared. So I'm going to bring that down here, x squared plus 2xh plus h squared. Go ahead and distribute that. So it's a negative 2x squared minus 4xh minus 2h squared. All right, so that's this part. Okay, I'm just going to carry everything else down. Plus x plus h plus 5. Okay. So now that I have that, I'm going to plug it into that formula, the f of x plus h minus f of x over h. All right, so this right here is just f of x plus h. So I'm going to rewrite it. Negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Okay, so that is this f of x plus h minus f of x. I'm going to subtract this whole thing, negative 2x squared plus x plus 5. Okay, so I had to put this in parentheses because I'm subtracting the whole thing. So whenever you do that, you can keep change, or go in and distribute a negative 1. So whenever you do that, this becomes, I'm going to rewrite it, negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Okay, so then negative times negative becomes positive 2x squared. Negative 1 times x is a negative x. Negative 1 times 5 is a negative 5. Okay, so let's see if I can simplify it. And then it'll all be over h once I simplify this. These are the same. That's the same. That's the same. So we're left with negative 4xh minus 2h squared plus h. Everything else canceled out, right? Do we have this plus h? Yeah. So it's 1, 2, 3 terms. And then it's all over h. So we can do like we did before. We can simplify this, this, and this. So whenever I do that, I'm going to rewrite it. Okay, so those cancel. Squared and h is cancel. H over h cancels to be 1. So this leaves us with negative 4x minus 2h plus 1. And all of these say when h cannot be equal to 0. And the reason they're saying that is because if I have h as a 0, it would become undefined because you can't divide by 0. All right, so that is it for 2.2. See y'all later.